Yeah. What are inner transition metal? What are inner transition metal? That is lanthanide and actinides. Can you tell me inner transition metal? Are you listening me?
Yes, sir, listening.
What are inner transition metal? So that is
F block.
F block elements are inner transition element. In these elements, the 4f and 5f orbital are progressively filled. The 4f series 4f series of the inner transition metal known as what? Lanthanide, and another is actinides. So leave this one. What are the position of the transition element in the periodic table? Position is between S block and P block. This is the position. Next question they are saying, that is, why does transition series contain 10 elements? Because they are filling, that is d subcell is getting filled now, and d orbital can have 10 electrons. So there each transition series consists of 10 elements because d subcell consists of 5 orbital and can accommodate 10 electrons. Next one, electronic configuration. What is the general electronic configuration? What is the general electronic configuration, Sarnay?
Sir, general electronic configuration, sir. 1 second, sir.
n-1 d1 to 10 or
NS1 to 2.
ns1 to 2. They are general electronic configuration. So that already we have done this one. Which element is having exceptional configuration? That is the general configuration n-1 d10 means 3d10 4s0, which is having this configuration. 4d10 5s0. This is the palladium. Palladium is having the exception. So they can write ask the electronic configuration of any of the element that you should know. Which one is copper and chromium is having exceptional. In spite of 3d4 4s2, they are having 3d5 4s1, and in spite of 3d9 4s2, they are having 3d10 4s1. Write the electronic configuration of chromium and copper. So you can already you are knowing this one, so no need to explain. Yes or no?
Yes, sir.
Why zinc, cadmium, mercury not regarded as transition element? That we have already done. On what ground basis scandium is the transition element, zinc is not? That already. What the reason can you give?
Sir, it has completely filled 3D.
Which zinc is completely filled 3D, but scandium is
No,
having
not zinc,
3D1.
sir. Scandium completely filled 3D.
Scandium is incompletely filled, na? Getting na? Hello?
Okay, okay. Getting, sir.
Scandium is incompletely filled, so they are regarded as transition metal. Zinc is fully filled, so they are not regarded as. Okay, next one. Physical properties. So they are what? They are the malleable, the ductile, high tensile strength, thermal and electrical conductivity, metallic luster. Okay, they hard. So all the property they are having. At room temperature, silver has the highest and copper has the close second electrical conductivity. So this is there. Melting and boiling point of transition elements are high. What is the reason behind this? What reason can you give? Why the melting and boiling point of transition metals are high? Yes or no? Why the melting and
Sir,
boiling point?
more number of unpaired electrons. So, sir, they all will be like involved in the formation processes.
So more number of unpaired electrons, so they will form the interatomic bond. And since they are forming interatomic bonds, so that is what melting and boiling point will be high. Here they are saying which element is having the highest melting point. So that is the tungsten. Tungsten is having highest 3422. And in contrast to the S block, that is 29 degrees C only. And here it is there 3422. What the reason they are giving for this one? They are saying due to involvement of greater number of unpaired electron from n-1d and ns orbital in the interatomic metallic bonding, greater the number of unpaired valence electron, stronger is the resultant metallic bonding in general. So melting point will be high. Next question they are saying melting point of and enthalpy of atomization rise to maximum D5 up to D5 which is increasing. The region is what is the number of unpaired electron. Then D6 is there now. In D6, 4 unpaired electron is there. 4 unpaired electron. But here how many are the 5 unpaired electron? So if you see this one, that is after D5, the melting and boiling point will decrease. The reason is what? The number of unpaired electron also decreases. Got it? Why do transition element exhibit high enthalpy of atomization? Enthalpy of atomization means conversion into what? Conversion into atoms. Enthalpy of atomization means conversion into atoms. You are going to convert into atoms. This is meaning of enthalpy of atomization. Getting? So since they are having a strong bond, so you if you want to break the bond, then only you can convert into atom now. So the reason they are saying enthalpy of atomization is amount of heat required to break the metal lattice to get free atom. The transition element have large number of unpaired electron in their atom, so they have a stronger interatomic bond. So higher enthalpy of atomization result from the stronger bonding between atoms. Are you getting this one?
Yes, sir.
Next one there. Melting point of zinc, mercury, how much? 420 degrees C and 39 degrees C. That is compared to 3000, it is less only. The minimum in the series. Why? Yesterday we wrote the maximum, but it is how much? Minimum. Yesterday we did mistake, but it is the minimum. What is the reason behind this? Relatively low melting point of zinc and mercury are due to absence of unpaired electron for metal bonding. Thus, metallic bond present in them are weak. So, if metallic bond is weak, so what is having? Low melting point, 420 minus 39. Got it?
Yes. Got it.
Which elements of the first transition series has lowest enthalpy of atomization?
Zinc, sir.
Zinc. Zinc is the answer. Okay, what the reason? Zinc, because it does not have unpaired electrons for metallic bonding due to completely filled valence shell. Okay, it is having the lowest enthalpy of atomization. Metal with very high enthalpy of atomization, very high boiling point, tend to be noble in their reactions. Okay, next one, question number 24. In comparison to element of first series, the metal of second and third series have greater enthalpy of atomization compared to first series. They are saying compared to first series, the second and third series have greater enthalpy of atomization. So this is due to occurrence of much more stronger metallic bonding in the compound of heavy transition. Heavy transition metal have more strong metallic bonding. So enthalpy of atomization to break the molecule to convert into atom will require more energy. Okay.
Sir.
Is it okay?
Hmm.
Hmm.
Sir, can you send
Unlike,
me this one, sir? I will then take a printout of the entire thing.
I will take the complete chapter I will give them.
Okay.
This is not fully. Okay, question number 25. Unlike chromium 3 plus, Mn2 plus, Fe3 plus, subsequent M2 plus ion of 3D series of element, the 4D and 5D series metallic generally do not form stable cationic species. They are saying subsequent other M2 plus ion of 3D series elements and 4D series, 5D series element do not form a stable cation like that. What the reason behind this? Reason they are saying because they have a strong metal-metal interaction between them due to the small size. As a consequence, the enthalpy of atomization of and ionization in values are higher, so they do not form the stable cation. Okay, since ionization enthalpy is high, so they are requiring more amount of energy, so they are not going to form this type of the bond, this type of ion. Well, the reason is why they are not forming the ions like this, because of high ionization energy. Now we are talking about the ionic size and atomic size, ionic size of the transition metal. This topic we are going to study. Up left to right, the this is the not a regular decreases, but not very regular. Sometime it is will increase, sometime it is going to decrease. So let us see the value of not there. Hmm. Just give me a moment. Yeah, just I want to show you something. That is why I'm taking. We are talking about size. Okay. Metallic radii. These are the there that you can see. Metallic and ionic radii. Okay. If in the form of atom, it is there the metal. So what is there? This is decreases. Yes or no?
Hmm.
164. Then what is there? 147, 135, 129 decreases. Then slightly increases. This increase. Then again got decreasing, then become little bit constant, then increase. Increases means what? Zinc is having 3D10 configuration now. So they were evolved repulsion. Repulsion means increase in the radii. Here is the nuclear charge increases. Similarly, if you are going ionic, you will find that it is going to little bit increase, then decrease. They are going to decrease. At the end, it is going to increase. Similarly, this one, these are going to decrease. So atomic radii is not having the what? That is the proper trends. What are the reason here? You see variation of atomic and ionic radii. Na? Are you seeing this one?
Sure, same.
Okay. They are saying in general, ions of the same charge in given series show progressive decrease in radius with increasing atomic number. So if you talk about the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So what they are saying here, it is going to decrease, and some places it is increase, some places it is the constant, not the very regular decrease. Up to middle it will decrease. This is because the new electron enters a d orbital each time the nuclear charge increases. Nuclear charge increases means number of proton increases, so they are attracting the electron. So since they will attract the electron, so size will decrease. It may be recalled that the shielding effect of d electron is not that effective. Shielding effect is what is d orbital and f orbital are very less. So shielding effect, what is z effective if we are writing? So what is z effective? Z minus shielding effect. Z minus shielding effect. So what is there? Shielding effect is almost zero. So Z effective what is there equal to the Z means what is the atomic number? So shielding effect decreasing means if effective nuclear charge increases. So more attraction. They are going to attract more attract. The net electrostatic attraction between nuclear charge and outer electron increases. Getting point? Nuclear charge means number of proton and outer electron increases. Thus ionic radii decreases. Are you getting this?
Yes, sir.
They are saying the same trend is observed in the atomic radii of the given series. However, variation within the series is quite small. Variation in series, it is not the very high or very low. The variation is little bit. An interesting point emerges that atomic size of one series are compared with those of the corresponding elements in the other series. The curve is so increased from 3D to 4D. Down the group, it is increasing. 3D to 4D, they are saying increase. That is increases. Okay, because size increases. Now, increases. But what they are saying? Series of the elements of radii. So, the increase from 3D to 4D series element. But here you see, but the radii of 5D series are virtually the same as those of the corresponding second series. So, if you are talking about 5D, they are the same. The reason is what is their lengthenoid contraction. Lengthenoid contraction. What is lengthenoid contraction? F orbital do not cause shielding effect. So no shielding effect, nuclear charge increase. So what will be there? More attraction. More attraction means small size. This phenomena associated with the intervention of 4f orbital. 4f orbital is involving from the 5D, which must be filled before 5D series of elements begin. The filling of 4f before 5D orbital result a regular decrease in atomic radii called the lengthenoid contraction. So here you see in the figure, these are almost constant. Can you see? Here is the change is there, but these are the very constant. Here you see constant, but here there is change. Can't you observe? Hello?
Sir, I am observing. Sir, mic was moved.
Okay. So this is because of lengthenoid contraction, which essentially compensated for the expected increase in the atomic size with increase in atomic number. Which one is lengthenoid contraction? What is lengthenoid contraction? Because between 4D and 5D, which one? 4f electron are filling. No shielding effect is there 4f. So what will be there? Contract. The net result of the lengthenoid contraction is that second and third D series exhibit similar radii. Example, they are saying zirconium and hafnium. Zirconium belong to that is 4D series and this is 5D series. Have very similar physical chemical properties, same radii in a picometer, much more than expected on the basis of usual. The reason is what? This, that is lengthenoid contraction. So what you come back, because it is only theory based, so you may be finding little bit uninteresting. Okay, now you see here in the given series of the ions, the same charge, so progress decrease in ionic radii, increase in atomic number. Why? So these are the see. What is their inner electron? Are there these inner electron? So inner electron, whatever there is, they are no shielding. No shielding. Here what is Z effective is equal to Z actual minus shielding. So no shielding. So inner electron no shielding means completely attracted. Completely attracted means what will be there? Small size. So in the absence of each time when the nuclear charge increases by unity, then the new electron enters d orbital. However, the shielding effect of d electron is not that effective. As a result, the net electrostatic attraction between nuclear charge and the outer electrons increases. Where nuclear charge and outer electron increases. As a result, ionic and atomic radii decreases. Are you getting this?
Hmm.
Are you sure or not?
Sure, sure.
Okay, question they are asking. Zirconium and hafnium have almost similar radii. Why? They ask in the CBSE exam. Many times they ask. What is the reason? Because of lengthenoid contraction. What's the reason? Because of lengthenoid contraction, 4D and 5D series, they are having same radii. Same radii. Reason is lengthenoid contraction. Next, the ability to blend together to form alloy is present in transition metals atom, but absent in main group elements. Why? So those who are having nearly similar radii, okay, they are saying to form the alloy. Those who are alloy formation, we will study separate heading. Those who are having similar radii, they form the alloy. Main group element, if you talk about main group like S block, so they lack because their radii are different. This is because all transition metal atoms have quite similar radii, but main group elements so large variation. So similar radii, if the radii is similar, so what is going to happen? They can form the alloy. Why do atomic size of 4D series greater than 3D series? 3D to 4D, they are increasing. Why? Number of cell increase. Number of cell is what is increase. And no lengthenoid actinoid contraction. An entire principal quantum number cell of electron are added. New cell added, na cell. So the size increase expected. So 3D to 4D, there is no problem. Down the group, it will increase. Density of 3D series element, they are increases from titanium to copper. Why they are decreasing? That is size decreases, na? Size decreases. Are you getting? D is equal to M by V. So this is volume decreases, size decreases, so density will increase. Are you getting?
Hmm.
This is due to increase in atomic mass coupled with the decrease in metallic radii. If the density of third series element are higher than the second series element, this is because atomic mass of third series element of transition elements are higher. So atomic number, atomic mass increases already. So D is equal to M by V. So this is increasing higher. Okay. Second series element. So even though the second and third series element have nearly same radii, same atomic volume, the much heavier third series element have more density. Okay, these are there. So atomic radii and ionic radii, what is happening, Sanoy? It is getting decreased. Where left to right, it is getting decreased. The reason behind this is, what is the reason behind this? Decrease in atomic radii. That is more force of attraction between nuclear charge and outermost electron. Why the force of attraction is more? Because of the less shielding effect. They are causing D block element causes less shielding effect, so more attraction, so radii will be what? Smaller. So
Smaller,
this
sir.
is the Now you see the other thing, enthalpy of atomization. We already done this one, enthalpy of atomization. Left to right, what is happening? 326, it is increasing. Because size decreases, na? Size decreases means strong bond. Otherwise, you can say number of unpaired electron increases. So here up to unpaired electron increases, so stronger metallic bond. So enthalpy of atomization increases. Then here is exception is there. Mn is exception. You can see the Mn. No, this is chromium. Chromium. Here is less. Mn is more exception. This is the Mn is exception. That is exception is not given in NCERT book. This is the exception. Then frequently because of the pairing of electron, it is going to decrease. Consequently, it is decreasing. More. This is so depending on number of unpaired electron. From the beginning, it is increasing 3D1. There na 3D1, 3D2, 3D3 increases. Then these are two are the exception. Ionization enthalpy, you see ionization. What is happening? 631, 656, 650, 653, 617, 762, 758. They are completely, they are going to increase. Okay, increasing. But here the copper to zinc is very high. 745 to 906. Reason is stable configuration. Stable, it is difficult to remove the electron from stable configuration. Therefore, zinc is having the high ionization energy. Okay, so we will cover this ionization energy. One more question you see. Question example number 8.2. Why do transition element exhibit higher enthalpy of atomization? Can you tell me? Hello.
Same reason only, sir. Large number of unpaired electrons.
Thank you. What about the question number 8.2? In text 1, in the series scandium to zinc, the enthalpy of atomization of zinc is lowest, 126 kilojoule. Reason? Why the
Sir,
enthalpy of
that is same only na, because the number of unpaired electron is increasing.
number of unpaired electron is 0. There is no unpaired electron, so metallic bonding will be weakest. So it
Sir,
will
I am
form
saying
the
it is increasing, sir, from St to Zn.
what's the name?
Sir, I am saying that the number of unpaired electron, it is increasing from St to Zn.
Zn, where is the unpaired electron? 0 unpaired electron. Up to Mn, up to chromium only it increases. Unpaired electron equal to 0. 3d10 is there na. D orbital 5 type. 1, 2, 3, 4. So it is having the no unpaired electron. So no unpaired electron means weakest bond. Weakest bond means what? Less energy required, 126. They are saying the enthalpy of atomization of zinc is lowest, 126. Reason? Weakest metallic bond. Getting? Hello.
Sir, getting.
Ionization enthalpy I will teach you the evening time. Okay, evening time means you join 10 p.m. Are you free 10 p.m.?
I am free, sir.
You join at 10 p.m. Now you can take rest. It is 2 going. I'm going little bit outside. That is why.
Okay. Okay.
Okay.
Okay. Thank you.
Meanwhile, you read the NCERT, na? D block element.
Sir, okay, sir. You asked me questions, sir, in the night session.